Welcome to another episode of Inside IALR. Daniel held down the fort for the last 4 episodes, and now I'm back on the mic. So this is a fun episode. We have a lot of really cool projects that we run out of our manufacturing advancement division, and several of those are in partnership with the U.S. Navy, and particularly working Maritime Industrial Base, formerly known as the Submarine Industrial Base, up until recently. And now we have 2 guests here with the Maritime Industrial Base. So we have Jesse Geisbert, who's the Advanced Manufacturing Director for the Maritime Industrial Base, and we have Aaron Wiest, who's the Additive Manufacturing Program Manager, also for the Maritime Industrial Base. And also, we have Jason Wells, our Executive Vice President of Manufacturing Advancement. So thank you all for being here.
Thanks for having us.
Thank you to be here.
So to start, let's talk a little bit big picture. What is the Maritime Industrial Base? We'll start there and see where we go.
So I would say if we're going to talk about Maritime Industrial Base, we should probably first talk about the Submarine Industrial Base. So where we started, there was a study done back in fiscal year 21 that looked at our ability to build 1 Columbia, 2 Virginia per year. And from that study came out that we needed multiple different thrusts. So one was in technology development, one was in workforce, one was in the supply chain, one was in infrastructure, strategic outsourcing, and that set a budget profile that was, I believe, unprecedented at the time to go after those initiatives. So our area, Aaron and I, we both originally worked in technology development for the Submarine Industrial Base. I was the Deputy Program Manager for that department or that division. Technology development, we recoined later to advanced manufacturing to try to protect, some of the stuff that we were doing, so that it wasn't viewed as like basic R&D type stuff in the budget, and then therefore get cut because it wasn't ready for. It wasn't viewed as like ready to actually move the needle. So what we focus on the advanced manufacturing side is how do we go support the 1+2 when it was the Submarine Industrial Base.
And those are, just for clarity, those are 2 different classes of submarine that you all are trying to produce one of each, or say the names again.
So the 1+2 phrase comes from 1 Columbia, 2 Virginia per year, which is what we've currently, by 26, right, which is when we get into that steady state production. But it's really more than that for Submarine Industrial Base. It was really 1 Columbia, 2 Virginias, plus AUKUS, plus sustainment. And while we're at it, at the EB Newport News Primes, what are they also touching? They're also touching carriers. And we have to, like I said, sustainment, make sure we had the fleet. So it quickly became this big picture. But at the end of the day, it was how do we use technology in the pillar that we work in to go help drive the 1+2 mission. That got additional, when we realized the amount of scope and work that we needed to go do was still above and beyond some of the funding. Our leadership was able to go get even more additional funding, even more unprecedented amount of funds, which was great to go help move the needle. And that's when some of the leadership said, hey, the Submarine Industrial Base is doing these great things. What about the other aspects of the Navy? What about the combatants? What about the auxiliaries? What about our aviation department? What about munitions? Right? It's how do we go help do everything the Submarine Industrial Base is doing successfully and apply that across the board. So that's where we transitioned from the SIB to the MIB. And the MIB was, I think, officially stood up September of this year, September 2024, with that mission of looking across the Maritime Industrial Base. So doing everything we were doing for the 1+2 mission, but for across the Maritime Industrial Base. And leveraging all the success from the MIB, we carried pretty much the same pillars and added a couple more. So it's still workforce, it's still advanced manufacturing, it's still supply chain, there's still infrastructure. And so our mission, I guess, today is carrying forward everything we did on the Submarine Industrial Base. How do we go get that readiness for our Navy at large to go do the missions that it needs to do?
I'd love to take a crack at that question as well.
Sure, yeah.
Reading the news last night was a little bit sobering. The Biden administration authorized Ukraine to use some of the munitions we've provided them for deeper attacks against Russia. And Russia has changed their nuclear posture and threatened retaliation. And the submarine service is called the silent service because for, 70 years now, we've maintained peace through power. There is, probably most of you have heard of mutually assured destruction. It's a terrifying concept as powers across the world with nuclear weapons truly have the ability to wipe out life. And so by maintaining submarines which have that ability, those are the Columbia class and the Ohio class, to retaliate, protect us in the event of a strike, we basically de-escalate that danger because nobody wants to risk that. The Virginia class are the attack submarines, and then we've got the entire surface fleet that allows us to forward project power. And so the Maritime Industrial Base is around to ensure that we have the capabilities we need anywhere on the planet, and that we can provide them with our shipbuilders with the workforce, our sub-tier suppliers with the equipment, and the base materials that they need, castings, forgings, additively manufactured material, machined parts, non-destructive testing. We're trying to ensure that our industrial base remains vibrant so that we can deter those aggressions.
Thank you both for that, great overview of sort of what you guys do and where you guys came from, and then Aaron for bringing it back to why that matters. I mean, that was going to be one of my questions.
It's a scary time right now.
No longer need to ask that question. Tell me a little bit about, big picture, some of the technology development that you all are working with in advanced manufacturing.
So advanced manufacturing on our program, we basically split it into three main pillars. One is additive manufacturing. I would say it's all under the umbrella of Industry 4.0. But where we started, additive manufacturing was the clear front runner, and that's what Aaron manages, the additive manufacturing program. What we're trying to do, I would say two main drivers is material availability, ensure material is available, and augment and support the workforce. And when you can do those two things, then you can support on-time delivery of components. And so our portfolio is broken down into three main sections: additive manufacturing, each with a series of additional projects and programs under Aaron, non-destructive testing, and industry, all the rest of Industry 4.0, but we basically called that one Industry 4.0. And so each one of those three programs has a series of programs and projects under it, again, that all go to support material availability, workforce augmentation for on-time delivery.
Jason, I'm gonna bring you in now. Can you give kind of a big picture overview of how here at IALR we are partnering with the Maritime Industrial Base? And also, I know our partnership with it, our partnership goes to the Navy beyond just the Maritime Industrial Base. So kind of talk about some of those legs of that partnership.
Jesse had a perfect segue into this. A lot of our initiatives here on campus, here at the Institute, aligned extremely well with the initiatives that were going on simultaneously within the SIB, which has become the MIB. So here on campus, and here in Danville, we're looking to recreate ourselves, rebuild ourselves to a bit as a community, and we saw our paths there being technology and workforce development. So we had a lot of those efforts already in place, already in motion for the last 10, 15 years of looking how can we build on creating world-class skilled labor and realizing that, for every one engineer you have to have a team of doers, technicians that are out there actually making parts, growing parts, welding parts, inspecting parts. And then also the building we're in right now, the CMA, was to focus in on technology implementation to help help elevate industry to meet demands, production demands, strengthen the industrial base here in our region, which now is starting to translate out nationally with our alignment and our programs with the Navy and with the Maritime Industrial Base. So it was a lot of the things that we had noticed on a regional level or on a local level were the same things that were being realized nationally. And when Navy, when IBAS and leaders within the DoD came to our community and saw that we were recognizing the same things on a regional level, they saw an opportunity to leverage some of the resources that we had put in place, some of the time we've already invested, the 10 years getting to that point, and saw that as an opportunity to partner with us here locally and leverage some of those investments that we've made here in the region and locally to really accelerate some of the efforts that they were looking to engage in.
And those main connection points, I guess, we have with the Navy would be, you want to give a quick
Yeah,
breakdown
certainly.
of those?
So we have really two extremely strong lines of effort here on campus. One is on the workforce development side, which is our accelerated training and defense manufacturing program. And the other is in what our optimization center, which we call the Center for Manufacturing Advancement, where we host and proudly house the AM Center of Excellence project for the Navy.
So that's what I want to spend the bulk of our time on today is the Additive Manufacturing Center of Excellence. I know there's been a lot that's happened in the last 2 years, and as that project has ramped up. So, I mean, for any of you, tell me a little bit about what that project is, and then kind of, I guess first we'll start with kind of what is the mission, what is the focus of that project, and then we'll get into some of the success and impact we're already seeing.
I got to be around for the beginning of the AM CoE. My colleague Larissa, who now is Jesse's deputy and leads up the Industry 4.0 efforts, helped with the kickoff, helped provide some of the initial Navy guidance for reaching the initial operating capability. And this was really the brainchild of the executive director of PEOSSBN. That's the Strategic Systems Program Office. Did I say that right? Strategic Submarines Program Office, sorry. And we needed a center that would kind of be the nexus of additive integration across the country, a place where commercial vendors could come and get the help and training and mentorship to basically be able to meet all of the Navy requirements, a place where the additive is new. There are still things we're learning in that manufacturing space. So the first time you make a part, you're likely to run into some issues. And the COE was willing to stand up and take it on the chin with some of those early issues, get through that, figure out best practices, and be able to push that out to the industrial base through technical data packages. Also be willing to house a library of those technical data packages that in traditional thought patterns are like a casting mold would be placed at a foundry somewhere. And every time you need to get that part, you need to go to that foundry because that's where you invested the millions of dollars for the casting mold. When you move to a digital paradigm and you have a digital casting mold or an additive data file that allows you to use a 3D printer and manufacture the shape that you need that will then later go through value-added processing, the CoE gets to be the repository of those for any of the companies that wish to join in that collaborative network and support the U.S. Navy. So the Center of Excellence had a whole lot of really valuable elements that we needed to accelerate additive manufacturing within the submarine and now Maritime Industrial Base.
Yeah, well said. I would pile onto that. There's a saying that I've heard, and I think it's appropriate. It's, put your money where your mouth is. And that's what Matt Sermon and Whitney Jones and Admiral Papano did, right? We had talked a talk about doing additive manufacturing and other things to help the 1+2 mission at the time. And this was a forcing function, right? Of something to industry that we could say, the Navy is serious about additive manufacturing, and we're so serious that we've stood up this capability and supported this capability, and anybody in the industrial base, go here first, right? And that was a direct shot to the shipbuilders that said, we are absolutely serious with the Navy about making investments outside of the shipbuilders directly that go to support, the on-time delivery. And what better place to put it than on the ATDM campus, right, where you're also getting that training. And so now you have a one-stop shop where it's a landing page or landing spot for industry to come learn about additive, get qualified, understand the Navy requirements. You have training. You can get your parts made. The prototype's not a production. It's never meant for a production run, but you can get that prototype made that can then go be farmed out with additional people that the AM CoE is connecting. It's being that connective tissue for the OEMs and the shipbuilders and the industrial base at large. And like I said, it's truly the Navy is serious about operationalizing this capability, and this is the investment we continue to make to go support that delivery.
One of the real perks of having the COE here on campus and in connection with ATDM, as Jesse had just mentioned, is a lot of times in industry you'll see technology created and then companies having to figure out how to adopt that technology, and then you'll see a lag time of how do they get their staff up to understand and appreciate and adopt that technology. The one thing that we're striving very hard for is to keep those two programs really connected, in the sense of making sure that the skilled labor that we are training to is training to the most relevant technology that is being developed in the COE, so we can minimize that lag time of adoption and that lag time of understanding and comprehension at the shop floor level or at the technician level. So it's extremely complementary, and I really admire what the Navy has done in realizing that and housing these two programs together on the same campus.
Yeah, Jason hit something. One of the big things that we've talked about is how do you go minimize the economic barrier to entry for some of these companies? So if you're a company that is struggling with your current value chain and you want to go bring in AM, but it's new and it's novel and you don't understand all the requirements, well, you have the COE that can start walking you through some of the requirements. And if you want to bring on capability inside your fence or work with somebody else, they can connect you with those people. And if you do bring it in your fence, right, there's avenues to go get supplier development funding or go make a request for supplier development funding so that the Navy can support economically you bringing that capability in. And then you can go get training graduates from the ATDM that have relevant experience at the AM CoE who can operate those machines. And if you have problem parts, the CoE can help you develop the AM data files or the technical data packages that will allow you to do serial production in your fence and give that back to you, right? And so if you're a company, the economic barrier to entry is designed to be near zero to get you back to on-time delivery of your component and a supportive workforce for those things. And what better time than ever to actually, again, get into additive manufacturing at what should be a near zero expense to a company.
And I guess that goes back to the importance of why you all are doing this work as the Navy, the Maritime Industrial Base. These investments are being made in allowing industrial companies, private sector companies, these resources because of how important this work is, that these submarines get produced. As you were saying, Aaron, that this is about global power and display of power, and there's a lot at stake here. So that makes sense that it's this level of investment going in and this level of resources available for these companies. I working for the Institute for Advanced Learning and Research, we were from the beginning, we've been all about public-private partnerships and working public sector, private sector, federal, state, local, kind of combining all of those things and working with all of those different entities and bringing them together. Talk about the AM CoE and how the AM CoE is a great example of what kind of public-private partnerships can look like.
We have an era of unprecedented collaboration. It is amazing to see companies willing to jump in, willing to share some of their IP actually to help the industrial base grow. The CoE ends up getting to kind of cross-pollinate between all of these companies where they come in. Obviously, they're very careful to protect industry IP, but in that spirit of collaboration, there will sometimes be best practices learned at one company that are allowed to be shared with another company. That phrase of rising tide lifts all boats is something we're actually seeing. In terms of the manufacturing, we have become a place that people, the MIB, the CoE, the industrial base, it's hard to separate sometimes in who's doing what. But there's a growing reputation within the Navy that when you have an urgent part that's needed and the supply system can't handle that request for whatever reason, sometimes the company's out of business, sometimes there's a huge backlog, sometimes it's a really hard to cast alloy, and the MIB, Our partners in NAVCO5 have an additive inbox, and a request can be sent saying, we can't get this part. We have seen examples where the COE by the next day has been able to turn on manufacturing. We've seen other examples where they can go out into the industrial base, which is the preferred route once a part is well known how to manufacture it, and get rapid turnaround times that can save months in terms of getting critical parts that provide mission capability back to the fleet.
That's exactly what I want to get to next, is sort of those stories that we've seen so far of, so basically, in the AM CoE, as you guys have said, it's making technical data packages and then being able to send those out to companies is the main idea, so that suppliers can know how to effectively use additive manufacturing to make these parts. But
Can I correct that slightly?
Yes.
There's absolutely a know-how for some companies. There are other companies that are technical leaders. They can do this in their sleep, but having that collaborative environment where they can work together provides value. So there's one element sometimes where a startup company might need that technical know-how that the COE can bring. There's another cross-pollination thing that I was mentioning earlier where that expertise can be shared among companies. But with that mission of the COE to be able to be an interface between the government and the industrial base, it's providing a lot of value, not always the maximum technical know-how, but often an engineering similarity between approaches. So if you've got 100 great ideas and we're all making parts in different ways, with additive manufacturing, there's enough variability you can actually inject uncertainty into the final product. And with the COE, having a technical data package, here's the recipe that we used, we know it works. That gives us kind of a baseline of, if you do it this way, at least we know it works. We're willing to learn more on the back end, but knowing it was made the same at company A, B, or C is a value to the Navy, because we don't have to worry that some of the innovation that could make it in through additive might actually create new phases or properties that could be detrimental to the end product.
That's a good way to think about it.
I want to make sure we give proper credit to the amazing engineering capabilities in our industrial base.
I think one of the things to add on to that I've found with the COE project that's been very helpful is having end-to-end capabilities, being able to go from having an additive part to all the various steps in between to actually a finished component. It allows us to learn things at each one of those stages that we can implement into a more well-rounded and complete end-to-end strategy. As Aaron had mentioned, and I agree, there's fantastic companies out there with tremendous technologies, but they may be very focused in, say, additive, and not completely understand the impacts that an additive part have on the subtractive side of the equation. When you get a near net shape on the subtractive side, at times you got to take into consideration where you leave material, where you leave supports, different things like that aren't always intuitive with a more traditionally cast or forged piece of material. So by having this all housed in one location and being able to do that first article and grab all that science and all that data and be able to collect it is truly a game changer that prevents you from hitting speed bumps along the road if a part is going from one vendor to a next to get to that finished endpoint.
And to add on to what you were saying, we get some really good schedule acceleration because you go next door and you can machine the part. You go within the same building and you can inspect the part, make sure it hits the dimensional tolerances. And so there's a really rapid loop. The Marine Corps have a doctrine, observe, orient, decide, act, OODA. And that happens so quickly at the COE because part comes in, you got the modelers. Then it gets printed, you got the machinists, then it needs to get inspected, and all of that can happen in a really quick turnaround time so that when there are inevitably hiccups in a new manufacturing process, those aren't taking you months to figure out, they could be taking hours to days.
So let's talk about some of those success stories we've seen so far, and some of as much detail as we can about I know I've heard just, word of mouth, some stories of ships being delayed, submarines that would have been delayed if not for the work happening here. So as many stories as we can and share and talk about with that, we would love to hear them.
I think I'll start with the first one. It actually happened twice. The Hilo hangar door bracket is, in my very limited understanding. It seems basically like that sensor on your garage door that allows you to know there's nothing in the path of the door that's going to open and close, and you've got to have this sensor in place for the helicopter door to open and close on our destroyers. This little bracket made out of 316 stainless steel, not available, going to delay a destroyer by months and prevent it from going out to do its mission. COE gets called, I think the first one was before 4th of July, was it? No, before
December
Christmas.
19th.
December
Yeah.
19th. And COE turned it around over the Christmas and New Year's holidays. I think 19 days was the turnaround time because of printing and machining and inspection and all the capabilities that were in one house and an incredibly dedicated workforce to be able to get that destroyer back out to its mission and let the helicopter door do its job. And it's crazy to think that a part that small could actually impact a billion-dollar
destroyer,
asset.
right.
Yeah, something huge, hundreds of millions at a minimum. And it happened again right before 4th of July. So within this 6 or 7 month period, 2 of these were needed. The TDP was already developed. The second turnaround was how long?
13 days.
13 days. So we...
And you said we would be talking about months if it was...
Yes.
Yeah, that part in particular is interesting. Is part of the helo hangar door assembly. That's considered part of that massive assembly that's on the boat. And so you can't buy the helo hangar door bracket in the supply system, which is one of the other challenges. And so they had engaged the OEM that said, like, what's the turnaround time for this, this subcomponent in the component that we purchased, the helo hangar door, system. And that's where it was, months on months. It was an indeterminate amount of time. And that puts the decision to the fleet of whether they send a destroyer out without that operational capability, which is bad, or they wait for that component to actually show up, or they come up with some other workaround. But the point is that the COE was there, ready to execute in an unprecedented amount of time, right? Like, no, I don't think anybody thought it would actually work. And it wasn't just printing. It was working with, this collaboration that Aaron was talking about. It was working with Philadelphia to say, like, okay, we're going to build this mock-up and get that tested out. Does it work? What adjustments do we need to make? Okay, we've made the adjustments. Now we hit print, right? And that was 19 days. And part of that 19 days, if I remember right, is because it had to go be sent off-site for heat treat before it came back. Well, that's one of the reasons why we made an investment into heat treat capabilities here at the COE to further, this idea of everything can happen under one roof, this vertically integrated facility, so that it's I don't remember ODA, right? It's right here in this building. You can make almost every decision and knowledge point that you have to before you say, yep, that part's good. We've talked about I think some of the only additional capabilities we've talked about. I don't think we've rogered up to them, but it's like, how do we get additional testing, like pressure testing and hydro testing, if you guys wanted to have that here? Because that's some of the common requirements on the components that we go forward through. Sometimes you need the whole assembly in order to do that, so it may or may not make sense to add that capability here. But going back to the win, 19 days was a record. Nobody thought was possible. And then the COE beat that the second time around in 13 days over both holidays while shipping the component out for heat treat that they couldn't control here in the building. So it's just impressive. Twice in the same year, like a destroyer, 2 different destroyers went out and were able to maintain their mission because of the COE.
And
The third time will be even faster now that we have heat treat. So.
Exactly.
Well, the benefit, I would say, the other benefit is the realization that, hey, this, as the earlier destroyers may get more weather damage on this component, like this component, this sub-assembly component may fail more and more. So we took this component and converted it into a procurable item in the stock system. So the COE led the ability for the industrial base now to go buy this component, so that the COE doesn't have to be on the hook for serial production. Right, the whole mission is to transfer that to the industrial base so that the industrial base can support, like it needs to support, the supply system. And now, because of the COE, we have a part that has a technical data package or an AM data file that now has a stock number system, or should very, very close to having a stock system number that can be procured. NAVSUP or DLA can actually go buy this now in the industrial base.
And imagine that scenario. 13 days could look like a really long time. We've got, I think, 3 activated suppliers, basically 3 companies that have gone through the process to prove to the Navy that they've met the tech pub requirements. They've got all of the engineering and technical prowess to provide good parts repeatably. I think there are another something like 10 companies in the queue right now working with the CoE. But imagine a future state where we've got companies in every state. That data file exists. Whether we need the part in Yokosuka, Japan, or Puget Sound, or Norfolk Naval Shipyard, we will hopefully have an activated supplier nearby with the right alloy already sitting in the machine, so that when the call comes in, that data file gets sent to the 3D printing company next door to the shipyard, and the part could be delivered the next day. That's the kind of dispersed manufacturing. And this actually happened in World War II. There's this wonderful book, Freedom's Forge. If you haven't had a chance to read it, highly recommend it. But basically, there were sewing clubs across the country where people would sew the parachutes. We distributed manufacturing in such an incredible way because there were jobs that could be done at the point of need. And 3D printing provides a modern, technologically enhanced way of doing that distributed manufacturing, where a part that can impact a mission can be produced in the small, who knows, it could be a small business located ideally next to the shipyard or regional maintenance center where the asset needs repair. And then thanks to our AM Afloat program, we are having 3D printers actually put on the ships that can do this, not even in a land-based location. So there's really a recognition within the Navy that additive manufacturing can provide some critical capability to the warfighter, and the CoE is a very important piece of that.
Jason, you want to give a quick overview of NASAM, since he mentioned the ships and submarines having
Sure,
3D
yeah.
printers?
So we started ATDM, the accelerated training program that we have, really is primarily focused on 5 skilled paths: machining, welding, fabricating, additive manufacturing, non-destructive testing, and quality metrology. But out of the recognition on the additive side and the growth of the additive side, and as Aaron just mentioned, putting some of the printers onto ships and onto bases and various repair centers within the military complex, they recognize the need to skill up some of their active duty sailors and Marines. So we've spun off a program that is the Naval Air. It's right now it's identified to Naval Air, but it's an additive manufacturing training program we call NASAM. It's a 6-week condensed program that's heavily focused for those particular sailors, active duty sailors and Marines that come here to get training specific on their equipment. Curriculum is set by them, but we help facilitate the curriculum and the education, the training, and make sure that the comprehension is there. And after that 6-week program, they return back to their assigned post, and then utilize those skills to help support our military efforts. That is now in its second year. We've had 6 cohorts come through. We've graduated 40 active duty sailors and Marines. We have another cohort ready to graduate in December, and we're excited to continue to see that program grow. The success of that program now has NAVC and some other folks also interested in seeing how they can take advantage of allowing us to facilitate some of that training efforts.
At the beginning of this, we were talking about the idea of all of this being on one campus, and it made sense that that the Navy looked at what was happening with. Well, I guess the Navy was involved in putting ATDM here to begin with, and accelerated training and defense manufacturing on the workforce side, but then also deciding we want the additive manufacturing technology development happening there too. And then having, now with NASAM as well, more workforce programs specifically for those active duty sailors and Marines. It's just cool to see all the different things happening on the same campus in partnership with the Navy. I know, Jason, last time you were on the podcast, we talked about that, of why in the world is the Navy investing so much in Danville? And when you it's not a place you would think of for the U.S. Navy to be, but it's really cool to see kind of all of this coming together, and how each thing connects and supports the other one. So.
It truly is, and it continues to evolve and grow in very positive directions. But I think one of the things we hear why Danville a lot, and as we mentioned about the leveraging some of our existing resources and infrastructure that we had started to put into place, but it's what we're dealing with is it's a national situation, so it doesn't need to be just Danville, and it doesn't need to be just near a sea, near a port. It's certainly something that needs to be a national presence.
I think one of the things, we've talked about, we had the question earlier about public-private partnerships. I think the COE's created a model, right, that we should be replicating. And the COE, like we talked about, was never meant for production, but there's nothing that, prevents us from creating this same model using a public-private partnership for production, intended for production. And I think, one of the things that we've championed, I know I championed with the COE, is, hey, go to the COE and see what they've done and understand their capabilities, because that's what we need. What stops us from getting something like the COE outside of every shipyard, right? That's intended for production, not the single data file, right? And all the regional maintenance centers. And then if you expand to the MIB, right, what about these, the private shipyards that are servicing the boats? How do we go take, what's in this building and scale that? Because, I'll do another nod back to a demand study that was completed this year. In order to meet the potential demand that's coming, right, we need hundreds of printers, which also means we need hundreds of skilled labor that's going to go operate those, which means we need hundreds of inspectors, which means we need hundreds of machinists. And so if you go and you just take what capability exists here, that to me is like a rinse, wash, and repeat model, right? If we get a better projection on what the demand is, which like we Navy don't control, which is a very hard part, but if we had a better handle of what we think that demand could be, this center is a model that should be repeated rigorously, like at multiple places around the country, so that, like Aaron was talking about, this distributed manufacturing approach, a Pac Northwest boat doesn't have to necessarily come to the COE for that first article production part that's then going to, an AM as a service provider. There's production capability like right outside of Pac Northwest, right? And the same thing in San Diego, and the same thing in Florida, and the same thing in Massachusetts, right? So to me, this building represents, like I keep saying it, a model to be repeated, and that's, I think, a testament to how well this facility was thought out and what capabilities were here. Because when you go and you look at, hey, in one building I can get 95% of the way through my value stream of producing a component. That's pretty impressive. And that doesn't have to go out. You don't have to outsource any of that. Like, that's pretty impressive.
I love to hear him say that because, here at the Institute, our mission is to be a catalyst for transformation. Initially it started out a regional catalyst for transformation, and now it's becoming a national catalyst for transformation. And I say that to say that, we are very open as an institute. One of the things I'm proud of sharing, the secret sauce with other communities, with other institutions, with other areas where we can replicate this and where we can expand upon this and scale this to a national level, because we do fully support the mission and we're proud to be a part of that mission, but we also know that it takes the whole nation. So we have proudly hosted many events and many people from different communities, from different states and different organizations to come here, see what we're doing, explain to them what we've done in order to get to this point, and be an active part in trying to help other communities replicate this, because that is our mission, is to be a catalyst for transformation.
Different countries, too. Right?
Good point.
We have used the COE as an example. Hey, Australia, right? You should, this is something that you should be looking at and considering, which they've come here, and different territories, right? Like when we talk about putting this kind of capability in Guam, it's like, hey, come look at the COE. Like this is what you need if you're going to be successful.
Yeah, we just had 5 ATDM students that went through ATDM, came over to the COE to understand it, and went back to Guam. So, yep, very much so.
I would like, before we get out of here, I want to hear one more great story of a ship or submarine or destroyer, or something where production would have caused a major delay and the COE was able to step in and help.
I'll make a recommendation, but I think Aaron can field it. So I would recommend the trash disposal unit.
Oh, yeah.
liner.
We want to go super unglamorous. Believe it or not, even when you're living under the water for weeks at a time, you generate trash. That trash has got to go somewhere. So there is a trash disposal unit on a submarine. And it is really integral. You got to be able to shoot that trash overboard. There's some pretty critical components that have to get in there. And one of them, the trash disposal unit liner, gets basically welded into a larger assembly. And you can't open it back up. You can't get the liner out. It is a critical step, even though it's a very unglamorous sounding part, that is necessary to the manufacturing of a submarine. One of our prime shipbuilders, we allowed to say names?
Sure.
Okay, Electric Boat and Newport News are working on those. I think this was an electric boat part of the module. This prime shipbuilder could not proceed without the casting. They'd had 6 of the castings that had all failed. It's a very hard to cast alloy, somewhat complex part, and they didn't have a path forward, which meant stalled submarine construction for one piece. And the COE, this is the one where the request comes in, it gets modeled, by the next day they're printing. Do you remember how long it was before the prototype was done?
I think it was a total of 9 days.
It was some crazy turnaround time for a part that has, I think, a year plus lead time, which had already elapsed, and then all of the ones in the warehouse were defective. And so the COE was able to turn this around once again, that looped manufacturing where here's what we've got. Is this prototype okay? Here's the modifications to make. Here's how we get to the right part. And I think a finished one is now with the shipbuilder, and submarine construction can resume.
That's
awesome.
insane. If you think about a single part holding up, so the way the shipbuilders do production, it's a parallel production, right? A staggered production, and so you have a unit now. I think it was 805. That is stopped, which means like everything else is very quickly going to catch up and bottleneck behind that, because the way they do the sequence construction, right? Like they all have a trash disposal unit right in there, and so if you don't get 805 fixed, you're not going to jump. 806 isn't going to jump 805, right? 807 is not going to jump them all. They all need that unit. And like Aaron said, 6 were delivered, 6 were defective, and 6 were rejected. And this component is so big that your alternatives aren't. Sometimes you'll hear people getting creative, like, oh, I'll get a billet and I'll hog this part out of a billet. But this component is so big that that's not an alternative. And so thankfully, right, like who's there? I would say to save the day, the COE is.
Who are you going to call?
Literally, I was talking with Phil yesterday, and he said, they got the call. It's like, you should make a skit out of it, right? They got the call in a parking lot, and within 3 hours, the part had started printing, right? Or they had the model confirmed, right? And it was just like, that was the power of a collaboration, the passion, I would say, of the people here at the COE. And then they worked 3 shifts, around the clock, right, to get this part produced in record time, a part that they had never made before, a part that was modeled in like 3 hours, right, the build strategy, how you're going to go do it, and just that, like, head down, let's go, we're going to go get this part printed and delivered back to the shipyard so that the shipyard can resume machining operations and actually keep full-scale submarine production going, like one part. In 9 days, the COE turned that around, and turned that around to where that, when successful, that opened up the aperture for the shipbuilder to say, okay, like what are my backup options if I don't want to keep relying on a casting, right? Or if I want to rely on a casting, but I also want to have this like parallel path to support. So that then opened their, I would say, aperture to say, okay, we're going to now go contract this component out to go be procured. And if it wasn't for the COE, like everything, what's the impact of that, right? And we often get challenged on metrics, right? Like, what's the impact of holding up a series of hulls that are in parallel construction? Like, can you quantify that?
Let's try. Let's look at the impact here.
Right.
One of them is Ohio-class submarines need to retire. Every day a Columbia is late is relying on a very amazingly capable asset, but a 40-year-old asset to keep doing its mission. When a Columbia gets out, it brings brand new capability, brand new deterrence, brand new safety to the world. When you Google the cost of a Columbia submarine, we are investing a lot in these really valuable assets. If you think that they've got a 30, 40-year lifetime, divide by that cost. We're looking at a value to the American taxpayer of somewhere in the neighborhood of $1 million a day for these assets. Every day that that's delayed just in economic terms is value that we're losing out on as a taxpayer. So whether it's world safety or whether it's getting your tax dollars at work a day earlier, those components being delayed make a big difference and have a high value to our nation and to our Navy.
May I ask a question? You mentioned Ohio class and the age of that particular class. Do you see value in what we're doing with the COE in helping sustain, that class as well, further? Because I have to assume as things start to age out, you also find that parts may be discontinued or no longer available, and so that may be an opportunity to do some reverse engineering. Is that also a credible use of the COE?
It is. We'd given you an example of surface ship sustainment. There are multiple examples of submarine sustainment, but you're going to have to invite us back to hear those. Unless Jesse wants to share.
Well, the quick one is 100%. So the Michigan project is a great example. It's a Ohio class. It's a BN that was converted to a GN boat, but the AM CoE, again, if you ask for 3 examples, like I think helo hanger door, trash disposal unit, the third one I would say is the Michigan tailpiece, right? And so we have a series. Long story short, we were able to hook up with Puget Sound and the Project Super out there, who has the USS Michigan coming into an extended availability in in 2025, calendar year 2025. And we said, here's a series of components. One of those are trim and drain valves. And of those trim and drain valves, the bodies and the tailpiece are always corroded because of their, what they experience operationally. And so they know that they're going to have to do some level of repair. And we said, hey, AM can come help. Like instead of planning some unknown timeline associated with those repairs, or relying on the stock system, which currently doesn't have anything available, or relying on a rolling cannibalization list from the other shipyards to go replace those, we can deliver a ready for install asset. The tailpiece is one of those components in there, and we leverage the COE to go print a tailpiece in laser powder bed fusion to show it can be done and that we can transfer. At the same time, they printed another one in wire arc DED, and at the same time, they printed a third one on a different machine in wire arc DED. And so in one place, now, yet again, we've created 2 different AM data files that can go be distributed if we want, or like when this part gets converted into a procurable item in the stock system. Well, now the AM CoE has helped open the aperture even further, right? Because we're not vendor locked into just powder bed companies. We're not just isolated to DED companies. You can go both. And I think we're awaiting the final results. But all indications say that here's now for a single component that the Michigan's 42 years old, so she's almost at the end unless they keep extending her. But there's other boats that are 20 years old, or I don't remember when the last Ohio was commissioned and delivered. But point being, like the Ohio class will be around still for quite a considerable amount of time, and these trim and drain valves will constantly need repair. And now through the COE and through the efforts that we've pushed, here's one component that is a pull through, frankly, on Columbia class, right? So we know it's used on Ohio's, we know it's used on Columbia. There's a very similar component used on Virginia that we can now go also create the technical data package for, that can go be procured in the stock system as a standalone component as opposed to the whole assembly. So it's enabling anybody who's doing maintenance and repair. You have another tool in your tool chest. If you're an OEM, you can use the same thing to support your faster on-time delivery of your component. And so to me, it's a win-win-win, all enabled by the COE being here doing that work.
Excellent. I could listen to these stories all day.
Yeah, no, this is awesome. Yeah, I think, Aaron, you're right. We got to invite you guys back.
Yeah, because I want to geek out with Aaron on
Yeah.
material science. So.
That one might be over my head.
Be careful.
Before we go, can you? I know I mentioned the idea when we talked, a little bit about the idea of public-private partnerships. Can we kind of give an overview, real quick, of the different organizations involved in the AM CoE, and then we'll wrap up with whatever other thoughts you guys parting thoughts you guys would want to share.
Yeah. So I hope I don't mess any of this up, but to my knowledge, the COE's really cool because it's a consortium of partners, right? So we obviously have Austal doing the oversight, the management of it, but then we have Phillips Federal, you have CCAM, Industrial Inspection Analysis, I think that's II's acronym, Fast Tech, and it's really, hopefully, I don't know if I've missed any of the consortium partners. I know I've missed them. Spectrum, right? The point being, it's I should memorize the banner. It's an impressive amount of
Meditoya helps support us on the
it's an
metrology
impressive
side.
amount of people that have all come together, recognizing that in that collaborative environment with I would say support and funding from the government in that public-private partnership, that collaborative environment is what enables the win, right? Like there's not a standalone, hey, the government's going to write a contract with Austal and a separate contract with Phillips. And it's like you would never get there. You would never get this kind of collaboration and power and speed. And so the COE having that consortium of partners that they're bringing in, plus the continued, I would say support and investment from the government enables this public-private partnership to be successful.
No, I was just no. He's absolutely correct, and I think the nice thing about having a consortium of partners also is that those partners also bring some outside perspectives as well. Phillips, for example, has divisions all across. In the machining side of the world, in the additive side of the world, they're dealing with customers and supplying equipment to customers all over, and have a lot of insights and lessons learned that they bring to the table, as well as IIA and Meditoya, and so it's that collaboration also brings in a lot of good different perspectives as well.
That's all the questions I have. I think this is a really cool project. I've enjoyed hearing about it from you guys because I've heard basically the idea of technical data packages. That's pretty much, and then a little bit of those word of mouth stories of oh, there was a ship that would have been delayed, except we made a part. That's the extent of what I had heard. So hearing all of this firsthand and hearing all these stories and the impact that this project is making for the U.S. Navy and for these ships and submarines and their suppliers. And as you said, Aaron, it goes to, if you want to think about it like national security, that's obviously the main point. But it goes back to economics and tax dollars too, if you want to think about it that way, that this place is making a difference, and that's really cool it's really cool for us to be able to host that on our campus and be a partner in that, and I just think this is super cool. So
I just want to say thanks. We don't do a good enough job, I would say, trying to show. So we broadcast these wins, all the way up to ASNRDA on our weekly and biweekly updates, but we don't do probably a good enough job of advertising at large, right? All of these wins, because frankly, it's just so fast, right? There's always these issues that need these solutions. So I think this podcast and getting this kind of word of mouth out is great. And so I would just say thanks for the opportunity to have yet another platform to share those kind of wins. Would love to come back when we rinse, wash, repeat this and keep broadcasting all the wins that the COE is providing.
Yeah.
There's also a piece of ask not what your country can do for you, but what you can do for your country. We are grateful to our warfighters because they give up so much in service of their country. There's a lot that machinists and 3D printer technicians and inspectors can give for their country too. And when I think about people sacrificing holidays to serve their country, missing out on time with their family in those precious moments because they see a mission and they realize that they have a part in our national security and in keeping our naval fleet doing its job to keep us and the world safe. It really touches me. It's part of why I'm proud to do the job that I do. You don't want me to have a weapon. I got terrible eyes. I can't shoot straight. But I do have a good brain. And people who have good machining skills, people who have good abilities to make things, have a way they can serve their country. And it doesn't have to be in uniform. And it can be at home. It can be at the workplace. And we're really grateful to the hard work you're doing here, to all of the people you're training in service of our nation. Thank you.
Thank you.
Well
said.
Thank you, guys.
Megabytes IALR's on-site cafe features everyday favorites, convenient ordering options, and an eager staff ready to welcome and serve you. Our enticing menus offer something for everyone, from a fresh, well-stocked salad bar, wraps, sandwiches, and our rotating hot buffet offered on Tuesday, Wednesday, and Thursday. Megabytes is open Monday through Friday from 9:15 a.m. until 1:30 p.m. To view menus and for more information, visit IALR.org/megabytes.